this a new one?
This is a new classification. That's an S, a solid, in parentheses.
That's a 3 or a 5 after the CA. Oh.
We have 4 kinds of symbols that can go in the parentheses after the formulas. Okay? S, L, G, and AQ. That's correct. And I was looking for it in the references here. I know.
Okay, we see it. Okay,
Right here. It's on page, what page is that? That's page 10. There's the symbols right there for you, listed out for you. Okay? All right.
Hold on.
So it's S for solid. In the parentheses will be letters that indicate the physical state. Okay? All right. Is this a 1-part or 2-part compound? 2 parts. Aluminum is a positive ion. Sulfate is a negative ion. Is this a 1-part or 2-part compound? 1-part compound is just calcium. Okay? How about this one? How about that one? 1. Okay. So here's what we have. We have a 1-part compound here. Or it's not even a compound. It's an element. And it goes in, and it's going to kick out aluminum and join up with a sulfate. And we get this right here. Okay? That's what a single replacement reaction is, where some elemental form by itself replaces something it's like in a compound. Single replacement. Some elemental form replaces something it's like in a compound. In a single replacement reaction, some elemental form replaces some elements it's like in a compound. So it's a single replacement reaction.
It replaces what again?
Some element that it's like in a compound.
You have to balance it, right?
Then you have to balance it. That's correct. So balance is compound. What now? What?
How do you know, like, I just got lost, like, when you told, when you like the CA, something, there's something with the aluminum?
The CA goes over here and kicks out the aluminum, and it replaces aluminum in a bond with this sulfate. So when an element that's by itself replaces an element that it's like in a compound, that's single replacement. And the reason these are alike is because they're both metals. So now we've got the aluminum over here by itself. Okay? Huh? Well, 3 times 1 S and 3 times 4 oxygens. Okay? Yeah.
On the reaction side with the SO4,
Mm-hmm.
and then there's that 3 subscripts right there.
Right.
What does that 3 apply to?
Everything inside the parentheses.
Okay, so it'd be 4 sulfurs and oxygen, right?
Well, the 3 here applies to everything inside the parentheses, so that means there's 3 times the 4 oxygens for a total of 12 oxygens, and 3 times the 1 sulfur for a total of 3 sulfurs. Okay, so 2 aluminums, 3 sulfurs, 12 oxygens, 1 calcium. Okay. Okay, so what are we going to balance last? Oxygen. What are we going to balance next to last? Well, hydrogens if we had them. We don't have any hydrogens here. But you do have to save oxygen for last. Always, when you're balancing equations, balance the oxygen last. Always balance the oxygen last. Okay, is that how you count them up?
Yeah.
All right, so let's balance them. Yeah. Just oxygen last. It doesn't matter about the rest of them. Just oxygen last and hydrogen next to last. If we have a hydrogen, we don't have a hydrogen here. Okay. All right, we're trying to get the elements, the number of atoms of each element to be exactly the same on both sides. So I have 2 aluminums on the left side, but I only have 1 aluminum over here on the right side. The only way to get those aluminums to work out is to put a 2 in front of this. You cannot change the formula, so you can't use subscripts. You have to put coefficients out in front. So we need 2 aluminums. That takes care of that one. Okay? I'm going to save oxygen for last, so the next one I want to go to is the sulfurs. And I have 3 sulfurs on the left, only 1 on the right. So how do I get the 3 sulfurs here? Yes, you put a 3 coefficient in front of the whole thing, which changes everything inside. So now I have 3 calciums. Mark through that and put a 3 there. 3 times 1 sulfur, that's 3 sulfurs. 3 times 4 oxygens, that's 12 oxygens. Okay? Now, only calcium now is unbalanced. I've got 3 calciums on this side. To get 3 calciums on this side, I put a coefficient 3, and now the whole thing's balanced. Okay?
Okay, sulfur is so because when you put the 3 in front of the CA, they went with the A?
The 3 coefficient applies to everything in the formula. The coefficients, listen, if I can have everybody's attention. If I can have everybody's attention. If I can have everybody's attention. Okay. Coefficients in front of the formula apply to everything in the formula. Okay. Subscripts only apply to the element it's next to, except when the subscript is outside of parentheses. Then it applies to everything inside the parentheses. That makes sense? All right. So that's an example of single replacement.